This is Shane Picard with another geometry video. Today we'll be talking about side, 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 and side angle side similarity. First, let's talk about side angle side similarity. We have this side angle side similarity theorem. Remember, we need to keep this distinct in our minds from the side angle side congruence theorem. Two different rules, they're applied in two different situations and they lead to two different conclusions. So be careful about that. It says if an angle of one triangle is congruent to an angle of a second triangle. Notice that the congruence question is still coming in here. The angles are congruent. It goes on, and the sides, including the two angles, are proportional. So that's a little bit different. Then the triangles are similar. So we're dealing with two angles that are congruent, but sides that are proportional. Those are the including sides. Here's an example. The first question we need to ask is, do we have congruent angles? We ask that question first because it's the easiest question to ask. In other words, there's not a lot of thought that needs to go into. You just ask the question whether the numbers are the same. So here we have congruent angles 80 and 80. The next question is whether the including sides, or the sides that include the angle, whether those including sides are proportional. So we need to run the math on that. The question is 4 over 6, as 4 compares to 6, is that equal to 5 over 7.5? That's the question, and I'll put a question mark there so we know that it's a question. Well, in order to answer that question, we just cross multiply 4 times 7.5. Does that equal 5 times 6? On the right side, that's easily seen as 30. You know, twice 7.5 is 15, and then multiplied by 2 again is 30. And so they are, in fact, proportional. So we can tell that these two triangles are similar. Let me just point out one thing that sometimes is a small issue, and that is, suppose these numbers were reversed. Suppose this were 7.5 and this was 6. I think you can tell, hopefully, that it's the same triangle. I just flipped it around, so to speak. I turned it around. So when you go to run the analysis on the similarity question, suppose we check we've got these angles that are congruent, and we're wondering whether we have side angle side similarity here. And we compare 4 to 7.5. And we ask whether that's equal to 5 over 6. Let's just run cross multiplication here. We have 24, 4 times 6. Does that equal 7.5 times 5? That's the question. Is 24 equal to 7.5 times 5? Well, 7 times 5 is 35, and 0.5 times 5 is 2.5, so that's 37.5. Does 24 equal 37.5? The answer is no, it doesn't. So it would be tempting to conclude that these are not similar triangles. That's not a correct conclusion because what's happened is we've just mismatched the sides. 7.5 does not correspond to 4. Remember, in geometry there's no left, right, up, or down, so just because the numbers don't match up in the first instance doesn't mean the triangles are not similar. These triangles are still similar. We just need to make sure we pair them up correctly, and then we will end up with similarity. So when you first run the numbers, don't just immediately jump to the conclusion. Make sure you check all the possibilities. Okay, let's look at the next one. The next rule is the side, side, side similarity theorem. And as you might guess, it says if the corresponding sides of triangles are proportional, then the triangles are similar. Now it's a question of comparing all the three sides. You might do this in an extended proportion. Let's see how that looks. Let's just assume that perhaps the 4 corresponds to the 6, the 5 to the 7.5, and the 8 to the 12. Of course, this is set up very nicely for us to do that. And so we ask the question, is 4 over 6 equal to 5 over 7.5? And is that equal to 8 over 12? Those are the questions we need to answer. There's a couple ways we can do this in an extended proportion. We can first look at this left side and do cross multiplication and see if the cross products are equal. And then we can look at this right portion. Or we can simply reduce all three of these fractions down and see what we come up with. 4 over 6 is equal to 2/3. 5 over 7.5, that's actually equal to 2/3 as well. And 8 over 12 is actually equal to 2/3. So we can see that all of these ratios are equal, which means the sides are all proportional. And that means, of course, that these two triangles are similar. So we have similarity by side, side, side. Those are the rules we need to learn in this section. There's just one more thing I'd like to talk about briefly. You may remember back in the congruence rules, we talked about a rule called angle-side angle. It was an angle-side angle congruence rule that said if two angles of one triangle are congruent to two angles in another triangle, and the included sides are congruent, then the triangles are congruent. Question, do we have an angle-side angle similarity theorem? Is there such a rule, an angle-side angle similarity theorem? The answer is no, there isn't one, for two reasons. Number one, we don't need it. And the reason we don't need it is because if we have angle-side angle, then we already have angle-angle. And we have an angle-angle similarity theorem, so therefore we don't need angle-side angle. It's more information than we need. The second reason is if I had angle-side angle, I only have one side as a basis of comparison. And one side by itself can never establish proportionality. So for instance, if I had two triangles, and let's just suppose this were 6 and this were 8, there's no way to establish, or to rule out for that matter, proportionality when I'm only dealing with two numbers. The best I can do is create a ratio. But remember, a proportion requires two ratios. And if I'm only dealing with one side, then that second ratio is missing. So when I talk about this idea or think about this idea of angle-side angle similarity, it's both too much information and at the same time not enough. So there is no such rule. That's all I have to talk about here with respect to these two rules, side angle side similarity and side 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 similarity. Make sure you start looking at the review problems. If you have any questions, as always, feel free to send me an email.